Hi everyone, my name is Paul Fisher from University of Florida, IFAS Extension. And in this, the first in our series of 5 tips for horticulture, I'm going to talk about taking samples and interpreting the results for a test of the chemical quality of your irrigation water for a greenhouse or nursery grower. And there are a number of potential issues that could come up from ions that are dissolved in your irrigation water. You might have hard water with calcium deposits on leaves or clogging irrigation emitters or making it difficult to dissolve pesticides. High alkalinity water is like dissolved limestone. With highly alkaline water, every time you irrigate, it's like you're adding lime to your container substrate and the pH rises over time. Iron and manganese and other heavy metals can accumulate in the plant, and iron and manganese can also have bacteria that cause a slimy mess in your irrigation system. They can also have rust particles that clog emitters. Sodium and chloride increase the electrical conductivity and make it harder for plants to take up water and nutrient ions. Nitrogen and phosphorus are fertilizers, but if they get into your runoff or into your irrigation pond, then they can cause algae and eutrophication, environmental pollution issues. And there are some ions such as boron or fluoride, which even at a very small parts per million level can cause toxicities in your plant. So it's important to do regular water testing. You can do weekly or monthly testing of pH, electrical conductivity, alkalinity on site. At least once a year, send a water sample off to a commercial horticulture lab for a complete analysis of pH, EC, alkalinity, all of the fertilizer, essential nutrients, and also other ions such as sodium chloride and fluoride. So you can collect a sample very simply by flushing water through your irrigation lines for 5 minutes or more, just so that you're not sampling the water that's been sitting in the pipes. You can use a container, for example, an empty drinking water bottle from water that you've purchased from a grocery store, or you could use a specialized container as shown here. Just flush it with that water, and typically you need around 2 cups of water for a lab to do a complete water analysis. You may want to send in both your water sample and also your nutrient solution for analysis. We have a tool online and a website called cleanwater3.org, and it was developed by Dr. Rosa Raudalis at University of Connecticut, Dr. Bruce Mackay from Thomas Bain Limited in New Zealand, and myself here at University of Florida. To use the WaterQual tool, first go to our website, cleanwater3.org, and this is a website with contributions from multiple researchers from different universities and USDA. Select Tools. You'll see there are a number of decision support tools related to irrigation and water quality. Come down and choose the WaterQual tool, which is the tool that we'll discuss today to interpret the quality of a water source for use of irrigation of plants in greenhouses and nurseries. Agree not to sue us. Choose your language, either English or Spanish. We'll use English here. And then enter in the results that you would get from your laboratory analysis of your irrigation water. We'll enter in an EC of 1.5 and a pH of 8 and an alkalinity of 279 parts per million of calcium carbonate equivalents. Come down and click on Interpret, and it will provide some interpretation of these numbers in terms of their suitability for irrigation of nursery crops. So for example, this is telling us that the pH and alkalinity levels are high, and so that may require some acidification in your spray tank. If you're a hydroponic grower, you're going to need to inject acid to lower the pH to 6. If you were irrigating containerized plants, then acidification may also be useful to reduce alkalinity and avoid an increase in substrate pH over time, but you might also choose to modify your fertilizer program to have more acidic ammonium and urea nitrogen as opposed to nitrate. So each type of issue that you have in your water is going to have a different solution. Calcium in hard water may require reverse osmosis, which is a form of membrane filtration. You might need to acidify your water to drop pH and keep the calcium in solution. And there are also some chelating agents available. High alkalinity water is usually counteracted with injection of an acid, sulfuric, nitric, or phosphoric acid. But you can also do some other counterbalancing factors, such as reducing the amount of limestone in your growing mix or using a higher ammonium fertilizer. Iron, manganese, and heavy metals, sometimes with a higher pH in the water or oxidation, then there can be some precipitation of those ions, and they can then be filtered out. There are also other possibilities, such as reverse osmosis. Again, is a suitable method to remediate high sodium and chloride, along with increased leaching of your fertilizer solution on plants to wash out the salts. High nitrogen and phosphorus is usually mostly a problem with runoff from your greenhouse or nursery, and you may need to use a constructed wetland to use plants and microbial processes to bind up that nitrogen and phosphorus. There are certain problems, such as high boron, which are really quite hard to work with. You may even need to change your crop selection to plants that are less sensitive to high boron. So 5 tips on chemical water quality for irrigation of greenhouses and nurseries. Sample regularly on site, and we mentioned pH, EC, and alkalinity as being parameters that you can easily measure. At least once a year, send in a water sample and perhaps your nutrient solution for a complete analysis by a laboratory so they can tell you exactly how many parts per million of each element are in your water. Use fact sheets or your online tool, WaterQual, that we talked about to interpret the results, and then take an appropriate action. Talk with experts such as university experts or consultants to decide on the appropriate remediation. And you can also find resources in the cleanwater3.org website or take one of our courses. We have courses in Greenhouse 101, hydroponics, nutrient management, and specifically on water quality and treatment that can all help you be more informed to make water treatment decisions. Thank you.